this problem we have a bobsled traveling in a circle, and that allows the bobsled to slide up this inclined wall without friction. And we are to solve for velocity and the normal force here in order for that to happen. This problem is similar to other problems we just worked in the last section, except for this time we have this rotational motion. And because of that rotational motion, we are going to have the coordinate system of n, and that means that we're going to be looking at a normal. Over here, we can still look at y, and that will help us find out the value for mg. That'll help us incorporate that. So let's work this problem using f equals ma in the normal direction as well as the vertical direction. And I've pulled down this free body diagram of just the sled, a zoomed in figure, and it's good to set this aside separately so you can look at just the forces. At f equals ma in the y direction, that equals 0. So this portion is going to be a static equation. And in the y, you have n times sine of 30 here, as well as the negative mg, and that all equals 0. Sine 30 equals 1/2, so solving for that you get 2 mg. Let's plug in what we know. So m is 630 kilograms. In gravity, we are in the metric system. So n equals 12.360 newtons. Now that we've solved for the normal force, we can solve for the acceleration in the normal direction because the normal force is the only force in the normal direction. So F equals ma. Here it is not equal to 0, so this is going to be the dynamic portion. And you get that n cosine 30 equals ma normal. And we know that a normal is v squared over rho. And that rho is that larger circle. So plugging everything in, you get 12,360 cosine of 30 equals 360 v squared over 50 meters. And in the end, you get that velocity is 29.1 meters per second. And that is how fast it needs to travel.